Welcome. In this video, we're going to look at this example of this question where we have this load that is being supported by this tension at this distance from the fixed point here. Then the distance is 1 meter, and then we have this 0.4 from this point to this point, meaning the total distance or the total length of the beam is 1.4 meters. And then this one, it is a uniform beam having the weight of 50 newtons. So weight of the beam is 50 newtons, and then the tension is 290. From this point, it is so much important that we come up with a free body diagram, of which this is the free body diagram that is here. So here we have this angle, which is the angle 37 degrees, and then we have the weight of the beam right in the middle, the midpoint of the beam, so it is just halfway from this point or from this point. Then we have this one, so we can resolve this in x and y components, where we have this one as j sine 37 degrees here, and then we have this one which will be at cos 37 degrees. So it is this one here, the horizontal component. Then from this point we can go on by finding. Now we are told to find the load, which is this one, the value of the load, then the FH, which is this one reacting in this direction, and the FB reacting upwards. This is the horizontal, and this one is the vertical. So the vertical forces, horizontal and vertical forces, respectively. So from this point, we can begin by saying, if we take the moment from this point, then all the forces that are here, the moment here will be zero. All the moments here will be zero. So we are going to say, taking moment at P. So taking the moment at P, the moments that are going to be produced by the upward forces and the moments that are going to be produced by the downward forces must be equal. So this one, so we have moment. So this was just an example. So we have the SCM must be equal to CM. So from this point, we can begin by saying, so the upward forces, the moment that is going to be produced by the upward forces, we have a force, we just have one, T sine 87 degrees times the distance from this to this is 1, because we know that moment is force times perpendicular distance. Then this must give us, it must be equal to, so we have the weight. Since the weight is simply in the middle, we have weight of the beam times 1.4, which is the total over 2, plus we have the L. So from this point to this point, it is L times 1.4 meters. So now we can plug in the values. We have 14, it is 290 sine 37 degrees times 1 meter, which must give us the weight of the beam, 50 newtons. Also 50 times 1.4 divided by 2 plus 1.4 meters L. So from this point, this into this, it is 25. So we have 25 newtons here. And then this one, we can make L the subject by simply subtracting this from this. When it crosses the cosine, we're going to have 290. So if we want to find the value of L, we divide by 1.4. meter, and also times 1 meter here, times 1 meter here. So meter here. So this and this will cancel, and we're going to have L is equal to 99.66 newtons, which can be rounded off to 99.7 newtons, and the value for L. So this is the value for L, and then without even wasting much time, we can go to the next question to find the value of FH. So to find that one, we know that summation of forces in X must give us 0 in order to keep the system in equilibrium. So we have this one pointing or acting in that direction. So we have FH. Then we have the horizontal component of the sine of this force, which is T cos 37. So minus T cos 37 degrees. This must be equal to 0. Making Fs the subject, we have T cos 37 degrees. Plugging in the value for T, we have 290 newtons cos 37 degrees. So punching this on a calculator, we're going to have 231.6 newtons as the horizontal force. And from this point, we can proceed to find the last one, where we have to find FV. Okay, so FV, we know that summation of forces in Y must give us 0. So our forces in Y, we have FV, which is pointing up, then plus T sine 37 degrees, pointing upwards again. Then we have the downward forces minus 50 newtons minus L. This must give us 0. So if we make FV the subject, we're going to have FV is equal to. Okay, so when this and this cross the equal sign, we're going to have 50 newtons plus L. Then this one will be negative minus T sine 37 degrees. So this one we're going to have 50 newtons plus the value of L, 99.7 newtons minus the value of T, 290 newtons sine 37 degrees. So this is going to give us negative 24.8 newtons.